Hello students. So what we will do now is we'll go to the next chapter. I hope you have worked out the first chapter. The first chapter was a relatively easy chapter. In fact, even this is a relatively easy chapter. I can assure you from the third chapter you will see good quality questions, and also you will see improvement in the way you are doing once you do what is being asked to do. So go through these solutions and then check out the different ways and the different styles in which we are working. Okay, so here is the first question. A stone is dropped from a certain height which can reach the ground in 5 seconds. So students, here I would just tell you some small things that you all have to understand. If it can reach the ground in 5 seconds, it means that it is being thrown from a point from where it will take 5 seconds to reach. So S is equal to half into 5 into 5 into 10. So that will make it from 125 meters. Not only that, by the time it reaches the base, its velocity will be 50 meters per second. Okay, then it is given to you that it was momentarily stopped after 3 seconds. So after 3 seconds it was stopped. So this will take half into 10 into 3 into 3. So this is 9 into 5 is 45. That means this distance is 80 meters. Now they are asking you the total time when the stone will take to reach the ground. So again, for 80, I will say it is equal to half into 10 into t squared. So here t will be equal to 4. So 4 plus 3, totally 7 seconds. So option C is the answer. In this particular chapter, it is very simple if you break the question into smaller parts and then work. So that is exactly what I did. I read the question, made meaning out of it, and then I worked it out. Second question, what are the speeds of two objects if when they move uniformly towards each other, they get 4 meters closer in 1 second? That means A is moving this way and B is moving this way. So in one way, they are coming closer by 4 meters. So do you understand that their combined velocity is 4 meters? That means VA plus VB is 4 meters. So let me look at the options. Option A is not the answer. Option B also cannot be the answer. Option this also cannot be the answer. C also cannot be the answer. Only possible option is D. Okay. So many times if you just read the question, try to understand what it means, it will work out more easily. Not only that, it also says that if they move in the same direction with their original speeds, they'll get 4 meters closer in 10 seconds. That means in 10 seconds they come 4 meters closer, means their difference in velocities will be 0.4 meters per second. Okay, so here it is not, here it is not, here also it is not. This is the only option which will work out. Okay, so I hope trains are each 50 meters long, moving parallelly towards each other at speeds of 10 and 15. So very clearly you can see that they are approaching each other at 10 and 15. That means in 1 second they come closer by 25 meters. Now each is 50 meters long. What time will they pass each other? Pass each other means they will be passing each other this way. So when they will be passing each other, this is total, they have passed each other. So the total distance should be 50 plus 50, 100. So 100 and then 25 means in 4 seconds they will pass each other. So 4 will be the right answer. A ball is dropped from the top of a building. Okay, here passing means what? This is train 1, this is train 2. When they have reached this particular configuration, that they have passed each other. So the total distance is 50 here, 50 here. So 50 plus 50 is 100. So 100 by 25. A ball is dropped from the top of a building 100 meters high. At the same instant, another ball is thrown vertically upwards with a velocity of 40 meters per second from the bottom. So there is a tall building 100 meters high. So from here something is dropped. So if something is dropped, I can say S is equal to half gt squared. So from here something is thrown up. So I can say that S is equal to ut minus half gt squared. Now the two balls will meet each other once together they have traveled 100. That means S1 plus S2 is equal to 100. So if I add them, these two will get cancelled. So I will simply get 100 is equal to 40t, or t is equal to 2.5 seconds. I wrote the equation for this, I wrote the equation for this. Those two will meet when together they travel 100 meters. So together if they travel 100 meters, 100 is equal to ut. So u is 40. So 40 by 100 by 40, 2.5. Okay. Particle is initially at rest. It is subjected to a linear acceleration as shown. The maximum speed attained by the particle is how much? So obviously in all such cases the maximum speed will be till that point where the acceleration is positive. So that means the entire duration the acceleration is positive, and they are asking me for speed. Speed is nothing but the area below this. So the area below this is half into 11 into 10. So that will be 55 meters per second. So at this particular instant the velocity will be 55 meters per second. So that is the answer. Okay. 4 persons, remember this concept anywhere. Suppose you are drawing stress versus strain graph. Stress versus strain graph. So the area below this will give you stress into strain, half of stress into strain. Okay, so this is nothing but the energy density. So whenever you see any graph of that kind, so PV graph. So this is the PV graph. So the area below the PV graph will give you the work done. Force versus displacement graph, the area below that will give you the work done. So here we have acceleration versus time. Since velocity is equal to acceleration into time, the area below this will give you the velocity. So we found out 4 persons A, B, C, D initially at the corners of a square of side of length A. If every person starts moving with same speed such that each one faces the other always, the person will meet after how much time? So there is this thing here, there's a square, this guy is moving towards this guy is moving towards this guy, and so on. So after some time this guy would be here, this guy would be here, so and this guy would be here and this guy would be here. So when I join them it will look like a square of this. So then again it will become a square of this. Ultimately they'll all meet at the center. Yeah. So if they are all meeting at the center, they are all traveling with the same speed y, same speed v, such that each one faces. So let me see what is the total net displacement that they are having. So the side is d, so this is d by root 2, the whole thing is root 2 d, half of it is d by root 2. So half of it is d by root 2 means it should be d by root 2 v. So there is an error here. This should be the right option. It should be d by root 2 into v. So there's a typo error here. If that is sorted out, it will be the right one. A man walks on a straight road from his home to a market 25 km away with a speed of 5 km per second. Finding the market is closed, he instantly turns and walks back home with a speed of 7.5. What is the magnitude of average velocity? Obviously he is going and coming back home, so average velocity is 0, displacement by time displacement is 0. Average speed of the man over the time taken, that means the man has gone from one point to another point at 5 kilometers per hour, returned at 7.5 kilometer per hour. The average velocity will be v1, 2 times v1 into v2 divided by v1 plus v2. So that will be 2 times 5 into 7.5 divided by 12.5. Okay, so this is 10, so it will become 75 divided by 12.5. So 75 by 12.5, 12 into 6 is 72. So it should be 6, option B. A starts from rest and moves with acceleration a1. 2 seconds after, B starts from rest and moves with an acceleration a2. If the displacement of A in the 5th second is same as that of B in the same interval. So now they are talking about in the 5. So A in the 5th second would have travelled half into A1 into 25 minus 16, that is 5 squared minus 4 squared. Now this must be equal to the distance travelled by B in 3 seconds. So that is equal to half into A2 into 9. So from here if I see, this is also 9, this is also 9, half cancels. So the ratio of their accelerations is 1:1. So I hope you understand this. Distance travelled by A1 in the 5th second is equal to the distance travelled by A2 in 5 seconds. But he started after 2 seconds. So he has moved only for 3 seconds. So I have worked with 3. A body travels 200 centimeters in the first 2 seconds and 220 centimeters in the next 4 seconds with deceleration. So for the first 2 seconds it is traveling, and then again 220 centimeters in the next 4 seconds with deceleration. The velocity of the body at the end of the 7th second is how much? So a body travels 200 centimeters in the first 2 seconds. So this is distance, this is time. So he travels 200 meters. So this is 2 meters. And then again and 220 in the next 4 seconds. So next 4 seconds he goes up to 220. Okay, this is 4 seconds. And then again with the deceleration. Okay, The velocity of the body at the end of the 7th second they are asking me. So there is nothing I can say about the 7th second. Okay, there is nothing I can say about the 7th second unless, let me see, let's assume that he started at rest. So from 0 he went to 2 meters in 2 seconds. So the average velocity V average is equal to 2 by 2, that is 1 meter per second. So average velocity is 1 meter per second. So the average, the acceleration is equal to 1 by 2, 0.5 meters per second squared. That is the first situation. So in the second situation, then at the end of 2 seconds his velocity is 2 meters per second. Now at the end of 4 seconds it travels 220. So average velocity will be 2 plus x by 4. 2 plus x by 4 is the average velocity. So this into 4 is equal to 2.2. So this will become 8.4 divided by 4. So rather this 4 will get cancelled. So x is equal to 0.2. Okay, that means after 6 seconds the velocity is 0.2 meters per second. Now at the end of the 7th second, now what is the deceleration also we can find out. So from 2 it has gone to 0.2, that means it has reduced by 1.8 in 4 seconds. So that is 0.45 meters per second squared. This is the deceleration. So from here now I can find out that velocity at the end of the next section will be 0.2 minus 0.45 into 1. So that will become 0.25, but is on the negative side. So I'll say that the body would have stopped by then. Okay, so I would say that he has stopped. A stone falls freely under gravity. It covers distance h1, h2, h3 in the first 5 seconds, the next 5 seconds, and the next 5 seconds. So there is a stone which is falling freely. So in the first 5 seconds, half into g into 5 squared. So this is h1. In the next seconds, it would be half into g into 10 squared minus 5 squared. In the next seconds, it would be half into g into 15 squared minus 10 squared. Okay, now let's see what are they asking. So they are asking me for the ratio. So we can find out very easily. So we can say that this is 5 squared. So I'll take 5 squared common in all the cases. So the h1 is equal to half g 5 squared is to half g 5 squared into, this is 4 minus 1, that is 3, is to, the next one would become half g 5 squared into, this would become 9 minus 4, that is 5. So if all this will get cancelled, so I can say that the h1 is equal to h2 by 3 is equal to h3 by 5. I hope you understood. What did I do? I broke up the distance. The distance travelled is half gt squared. So here, here, here. So I just found out each of those distances. Then I took the ratio. I took half g 5 square common, half g 5 square common. So it became 3 squared minus 2 squared. So that is 5. And then I found this. An automobile travelling with a speed of 60 kilometers per hour can brake to stop within a distance of 20 meters. Okay. If the car is going twice as fast, then what will be the stopping distance? There are different ways in which you can answer. I would like to use work power energy to answer this. So at 60 kilometers per hour, for him to brake 20, suppose the braking force is F. So I can say F into 20 is the work done, whatever is the work done. Now when the velocity has doubled, the energy will become 4 times. So for 4 times, what will be the distance? It will be 80. Yeah. Now I didn't use motion in a single in a plane to answer this, because to convert 60 kilometers per hour into meters per second, I would get a 5 by 18. So that would be a very wrong and bad number for me to work with. It would take me a long time. So what did I do? I said, according to the work energy theorem, work done is equal to change in kinetic energy. So if the velocity is 60, suppose W was the kinetic energy. If the velocity is 120, 4W will be the kinetic energy, half mv squared. V is doubled, 2v the whole squared. So it will become 4 times. So 4 times. So 4 times means it will become, a police party is moving in a jeep at a constant speed v. They saw a thief at a distance x on a motorcycle which is at rest. So there is a police party which is moving with a constant speed v. They saw a thief at a distance x. At a distance x, there is a thief which is at rest. The moment the police saw the thief started with a constant acceleration alpha. So this guy is moving with a constant acceleration alpha. So So the distance traveled by the police guy would be half, would be simply v into t, because he is moving at the constant speed, v into t, while the distance traveled by this guy would be half into alpha t squared. Now when will the police be able to catch the thief? If this distance is less than this distance, or if the difference between these two distances, the gap between them, is equal to x. So if vt minus half alpha t squared is equal to x, or greater than x, they will meet. So let's see. So I can also do it this way. I can look at their relative velocities, because there's nothing increase. Okay, vt is equal to x plus y, then half into alpha t squared is equal to y, or if I look at this, v squared is equal to 2 times alpha x. Yeah, so let's understand this. So this guy is moving. Now understand, the moment this guy's velocity becomes more than v, the police will never be able to catch him. Okay, so let's find out the time taken for his velocity to become v. So time will become equal to v by alpha. That means after v by alpha time, his velocity will become more than v. Now during that much time, this guy should have traveled x distance more, like this. So v into v by alpha minus half into alpha into v squared by alpha squared should be equal to x. So one alpha gets cancelled. So from there I can say that x is equal to v squared alpha, v squared x is equal to, this is v squared by alpha, half of v squared by alpha is equal to x. So yeah, so from there we'll get it. So v squared is greater than 2 alpha x. So if this is the case, the police will be able to catch him, otherwise they'll not be able to catch him. I'll explain again. Let me just clear it, then I'll explain again. See, the police is here, the police is traveling with a constant velocity. So v, the thief is here, this distance is x, and the thief is accelerating alpha. Understand that if the thief's velocity becomes more than v, then the police will never be able to catch him. In other words, t is equal to v by alpha. That means if the police has to catch him, they can catch him only if the time interval is less than v by alpha. If the time interval is more than v by alpha, they cannot catch him. So now in that much time, the police has to travel x distance more. So I said v into t, t is v by alpha, should be greater than, or this minus distance traveled by that guy, half times half a t squared, half alpha vt the whole squared. So half alpha v squared by alpha, this should be greater than, this should be greater than this. So when you are subtracting this, it should be greater than 0. So for this half alpha, so I will get half times v squared by alpha is greater than x, or v squared is greater than 2 alpha x. So I said C is the right answer. Velocity of a body moving with uniform acceleration of 3 meters is changed through 30 meters in certain time. So it's very simple. Changed through 30 meters means delta v is 30. So 30 by t is equal to 3. In other words, t is equal to 10 seconds. Okay. Now average velocity of the body during this time is 30 meters per second. Okay, distance covered during this time is how much they are asking. No problem. So we have already found out 10. The average velocity is given. So distance is time into average velocity. So 300. Okay, students, remember you can use S is equal to ut plus half a t squared, v square minus u square equals 2as, and v is equal to u plus at to answer these questions. But there is another way to do it, which comes from the derivation of these concepts. That is, v average is equal to u plus v by 2, then displacement is equal to v average into time, then acceleration is equal to delta v by time. Now if these are the concepts that we have used to derive these, now many times this is more easy to use this than this to work out these questions. That's why I appreciate this question. You can work it out this way also, but it will take you so much more time. Okay, a person is running at his maximum speed of 4 meters per second to catch a train. When he is 6 meters from the door of the compartment, the train starts to leave at a constant acceleration of 2 meters per second. Find how long it takes him to catch up with the train. No problem, assuming he takes time t. So the distance traveled is 4t. During the same time, the train would have travelled half into 2 into t squared, and this should be equal to the distance separating them. So the distance separating them is 6 meters. 6 meters. So if I get the value for t, my job is done. So let me substitute 2 here. 8 minus 4 is 4, not working. 3, if I substitute, 4 into 3 is 12. This is 9. 12 minus 9 is 6, not working. 4 seconds if I put, this is 16. This is 4 into 4 is 16. So it doesn't work out. None of these. So none of these is the correct answer. So none of these options work out. I substituted. When I substitute 2, this is 8 here. 2 cancel. This is 4 here. 8 minus 4 is not equal to 6. What have I done? The distance travelled by the man minus the distance travelled by the train should be equal to 6. Okay. Now here one intelligent question that you may ask is, every compartment has 2 doors. If he was a smart guy who has learnt physics, he would not try to catch up with this door, he would try to catch up with this door. Now assuming that he has learnt physics, and if he has to catch up with this door, now if I do plus, it should be equal to 6. Now none of these times, if I put 2, none of these will match. So anyway, there is an error here. None of them is the correct answer. Two bodies of different masses, MA and MB, are dropped from 2 different heights, that is A and B. The ratio of times taken by them to drop through these distances, how much? Two bodies of different masses, MA and NB, are dropped through 2 different heights. The ratio of times taken by them to drop through these distances. Okay, so A is equal to half A t squared. So this is, so T1 is equal to A by G1, 2A by G1 square root. T2 will become equal to square root of 2b by g. So T1 by T2 will become root a by root b. The distance travelled by a body during the last second of its upward journey is d. So the body was sent upwards. The last second means here it would be 0, here it would be 10. So that means b itself is equal to 5. So this is equal to 5. When the body is projected with a certain velocity vertically upwards. If the velocity of projection is doubled, then the distance travelled by the body during the last second would always be the same. Yeah, because we found out already that d is equal to 5. This is the last second. It's a very powerful concept. Please understand this. What am I doing? I am reading the question and I am trying to picturize. Now I understand what is the meaning of acceleration. Suppose a body was projected upwards at 50 meters per second. After first second, its velocity would be 40. After one more second, the velocity would be 30. After one more second, the velocity would be 20. Then again 10, and then again 0. Now this distance is average velocity into time. So this is 10, 0, average is 5. So 5 into 1 is 5. So this distance is 5. So like that I can calculate for everything. So now when I break up the question into smaller parts, there is a very elegant solution which has come up. A rocket is fired and ascends with constant vertical acceleration of 10 meters per second squared for 1 minute. Its fuel is exhausted and it continues the maximum altitude reached by the particle. So we can find out. So if it is 10 meters per second, so first it was 0, then it accelerated at 10 meters per second for 1 minute. So that is 60 seconds. So it reached 600. So here the average velocity is 300. So 300 into 60 will give you 18 with 3 zeros. After this, it again went up and then it stopped. Again the average velocity is 300, but this time it will take, this is 600 meters per second, so it will take another 60 seconds to become 0. Yeah, so it is 300 into 60. So into 60 will give you double that. So totally it will become 36 kilometers. So option is 36 kilometers. I hope you understand, because it is 1 minute 60 seconds. So by the time it reaches till it accelerates, it will be 600 meters per second. So during this time, the distance travelled is average velocity into time. So average velocity is 300, 300 into 60 is 18,000. Similarly, from 600 it will go to 0. Again it will take same 60 seconds because gravity is 10. So velocity 600 by 10 will give you 60, that is 1 minute. So now 600 into 300 will be the new, 60 into 300 will be the new distance. So 18,000 plus 18,000. That will give you 36 kilometers. A parachutist, after bailing out, falls 50 meters without friction. When the parachute opens, it decelerates at 2 meters per second squared. He reaches the ground with a speed of 3 meters per second. At what height did he bail out? Okay, no problem. So what happens is, first the parachute is falling without friction for 50 meters. 50 meters. Okay, here his velocity was 0 and then again he fell for 50 meters. Suppose his velocity here is v, then now what will be the average velocity? Average velocity will be v by 2, and v by 2 into time will be equal to 50. But now there are too many variables, so what will I do? I'll use v squared minus u squared equals to as. So v square is how much? V square is equal to 2 into 50 into 10. So v is equal to square root of this, so that is 500 into 2000. So this will become 1000, 10, yeah, 1000. So it will become 10 root 2. Now he is decelerating at 5 meters per second and he reaches the ground at 3 meters per second. So this will become approximately 14 point some distance, 14.14. So now he is decelerating at 2 meters per second squared. So again I'll use v square minus u square. So 1000 minus 9 is equal to 2 into acceleration is given 2 into s. So this will be 991 by 4. So s will become equal to 991 by 4, that is approximately 250 plus 50, so 300, but it is less than 250, so less than 250 close to 300, option C is the answer. Remember, in any of these exams they give you marks for ticking the right answer, they don't give you marks to find out the right answer and then do the answer. So I just do it approximately. Assume it was 1000 by 4 would have been 250 plus 50 would have been 300. So the answer is close to 300, but this is less than 250. So 293 is the right one. A body is thrown vertically upwards with an initial velocity u and it reaches a maximum height in 6 seconds. Okay, so from here you can make out that u must be equal to 60. It was thrown vertically and maximum height in 6. So 60 meters per second it was thrown up. The ratio of the distance travelled by the body in the first second to the 7th second. So now first second he is travelling from here to here, so 60 would become 50, average velocity is 55 into 1, so this is the distance travelled in the first second. Then he went up 6 seconds, 7 seconds from here to here, already we have found out 5, so the ratio will be 11:1, so 11:1. Again I'll explain from here. 60 meters per second, so 1 second it becomes 50, 40, 30, 20, 10, 0. So after 6 seconds it becomes 0. So 7th will come here. So from here to here this distance is 5. And then from here to here this is 60, this is 50, this is 40, this is 30, this is 20, this is 10. So this is average is 55. So this distance is 55. Here average is 45. So this distance is 45. This distance is 35. This distance is 25, 15 and 5. Okay, from a building, two balls A and B are thrown such that A is thrown upwards and B is thrown downwards, both vertically with same speed. If VA and VB are the respective speeds on reaching the ground, then obviously the first ball which was thrown up will go up to a greater height and then it will come. But let's see, from here both were thrown. So this was thrown up with some velocity VA, this was thrown with some velocity VA. Remember, the velocity at the lowermost point will depend upon the total energy. Now energy is not a vector quantity. So here the energy is mgh plus half mv squared. Here also the energy is mgh plus half mv squared. Now this potential plus kinetic will become kinetic. So in both the cases the velocities will be the same. So VA must be equal to VB, because their initial energies are the same. A boy throws n balls per second at regular intervals of time. When the first ball reaches a maximum height, he throws the second one vertically up. The maximum height reached by each ball is how much? Okay, so the boy is throwing balls, n balls per second at regular intervals of time. When the first ball reaches the maximum height, the second one is thrown vertically upwards. So when the first guy reaches, only the second one is thrown. So the time interval is so adjusted. So he is not throwing n balls. He is throwing 3 balls. So that when he throws the second one, the first one has reached here. Then he throws the third one when the first one just is about to reach his hand. So there are 3 balls which he is throwing, and in regular intervals of time. Okay, so we'll go by that 3 n balls per second. So n balls per second means each ball is going up for 1 by n seconds. So the maximum height reached is half into g into 1 by n squared. So that will become equal to g squared by 2n. So g squared by, sorry, g by 2n squared. So option B is the right one. But we could find out n also, n is 3. A ball, but that is the condition that he has to catch it. A body is thrown vertically upwards from a point A, 125 above the ground. It goes maximum height of 250 above the ground. So this is ground, 125, it goes up and then comes down. It passes through A on its downward journey. The velocity of the body when it is at a height 70 meters above the ground is how much? Okay, interesting. So this is 125. From here to here is 125. So from here I can say 125 is equal to 10 into t squared by 2. So this is 5. So t is 25. T squared is 25. So t is equal to 5. That means it is throwing with 50 meters per second. Then they are asking you what is the velocity of the body when it is at a height 70 meters above the ground. 70 meters above the ground. So we can use energy and then work it out. The initial energy is m 125 into 10 plus half into m into 50 squared is equal to half into m into v square plus m into g into 70. Okay, so now we will get the answer. So this is the initial energy when it was here, and this is the energy at this particular point. Energy is conserved. So first all the m's I can cancel, then again this 0 by 10 I will make it, and this 0 I can cancel. So I'll bring that 70 this side. So I'll get 55 plus this is 250 by 2, 125 is equal to v squared by 20. So 55 and this is how much? 180. So this is equal to 180. So 180 into 20. So square root. So this is equal to 3 into 20. So 60 meters per second. 60 meters per second. Okay, so I hope you understand how I approach. A body is released from the top of a tower of height h. After 2 seconds it is stopped and then instantaneously released. This is similar to the first one that we worked it. What will be its height after the next 2 seconds? Okay, so a body is released from a height of h, then after 2 seconds it is stopped. So after 2 seconds means it would have traveled half 20 meters. Half into 10 into 2 into 2, 2 cancelled, so 20 meters. So this full thing is h. So now it is h minus 20. So now this distance is h minus 20. Now it is stopped and then again released. So after 2 seconds again it will travel 20. So answer is h minus 40. Two particles move along x-axis in the same direction with uniform velocities 8 and 4. So two particles move along the x-axis with 8 meters per second and 4 meters per second with uniform velocities in the same direction. Initially the first particle is 20 meters to the left of the origin. So let's call this first particle, let's call this is the origin, this is 21 meters. To the left of the origin is this side. So this is first particle, 8 meters per second, 21 meters, this is the origin. And the second one is 7 meters to the right. So the second one is 7 meters, this is traveling at 4 meters per second, 7 meters. Now they'll ask you where will they meet. Very simple, the distance between them is 28 meters and the relative velocity is 4. So they will take 7 seconds to meet. So in 7 seconds this first particle would have traveled 7 into 4, 28. So 28 plus 7, 28 plus 7 is 35. So 35 distance to the right. Okay, so I hope you understand. The two particles are moving in the same direction. So in 1 second this one will travel 4 meters per second more than the other one. Now when he overcomes 28 meters, those two will meet. So 28 divided by 4, so that is 7. Okay, so in 7 seconds they will meet. In 7 seconds the first particle would have traveled 28. So 28 plus 7, 35 from the origin. So that is where they meet. A particle shows distance time graph as given. The maximum instantaneous velocity of the particle is. The distance time graph is given. So the slope of this will give you the velocity. So slope will be maximum to my knowledge at B. So at B I will say the slope is maximum. So velocity is maximum at 26th one. If a body loses half of its velocity on penetrating 3 centimeters of a wooden block, then how much will it penetrate more before coming to rest? So now half of its velocity is lost in 3 centimeters. So suppose its energy was E. So half of it is lost means 1/4 of it is half of the velocity is lost. Half of the velocity means 3/4. See, initially its velocity was v, so energy is half mv squared. Finally the velocity is v by 2, so it is half mv squared, but it will be 1/4 of this. So can I say 3/4 of the energy was lost? So 3/4 of half mv square is equal to force into distance. Now for the other 1/4 of half mv square, what will it be? Force into distance by 4, because this is 3/4, this is 1/4, so it will become by 3. So what will be the answer? 3 by 3 will be 1 centimeter, so it will take 1 centimeter. In other words, if this is a block, when it goes half of it, when it goes 3 centimeters, 3/4 energy is lost. So for the next 1 more centimeter, full energy will be lost. Okay, these questions can be done by v square minus u square also. It's not a problem, we can do it. So initial velocity is v squared minus v squared by 4 is equal to 2 into a into 3. Then v squared by 4 minus 0 is equal to 2 into a into x. So now when you compare them, you will get x is equal to 1 centimeter. Okay. A car moving with a speed of 50 kilometers per hour can be stopped by brakes after at least 6 meters. If the same car is moving with the speed of 100, we already worked it out. Now the energy is becoming 4 times. If the energy is becoming 4 times, the distance will also become 4 times. So 24 is the answer. A particle moving with a constant acceleration describes in the last second of its motion 36% of its whole distance. Okay, if it starts from rest, how long is the particle in motion and through what distance does it move? If it describes 6 centimeters in the first second, so particle is moving from here and it is going in the last second it does 36% of its distance. Then they are asking in the first second it does only 6 centimeters. So what can I say? Can I say if the velocity here is v, then average velocity is v by 2, so v by 2 into 1 is equal to 0.06. so from there v is equal to 0.12. that means a is equal to 0.12 meters per second squared. Yeah, so a is equal to 0.12 meters per second squared. Then what is it saying? And then what is the distance traveled? Let's find out what is the distance traveled in the last second. So the distance traveled in the last second is s is equal to half a t squared, that is s last. S pre-final will be equal to half a t minus 1 the whole squared. So when you subtract them, it will become half a t squared minus this, so that will become 2t minus 1, that is equal to 0.36 times half a t squared. So what can I do? Half can get cancelled, the a can get cancelled. Then I have a nice equation which I will solve. I'll write this as 36 by 100. So I'll get 2t minus 1. 100 times 2t minus 1 is equal to 36 times t squared. So some numbers I'll cancel, 4 will go, this is 25, or 9t squared minus 50t plus 50t minus 25 is equal to 0. Now let me see which of these numbers will be. I'll first try to put, let's say, this one and then see. So if we put t is equal to 10, this t square, so this is 900, 500 doesn't match. Then I'll put 15 and then check, 15 square is 225. So 9 into 225 plus, oh no, there is an error. The way I have written, this should be minus and this should be plus. So let me just do it again. So 9 into t squared, so 9 into 225 plus 25 is 2, so this is 250. 250 is equal to 50 into 15, no, so 10 centimeters may work. So this is 10 seconds means this will be 900, that is also not working. So 20, if I put 5, if I put t squared is 25, 9 into 25 is 225, 250, so this is the answer. I got the equation. Once I got the equation, I'm just checking. It took me a little time. So this should, I could have factorized it and then tried to work it out. But anyway, this is the answer. Okay, I worked out because all these numbers are different. If I find the time, everything else will be working out. So I just put this and I got it. Splash of sound was heard 5.35 seconds after dropping a stone into a well so much deep. The velocity of the sound in air is how much? Okay, so this is a good question. So first, if there is a stone here, stone will take some time plus sound will take some time. So sound will take 122.5 by velocity of sound. Stone would take s is equal to half gt squared. So I will get plus square root of 2s by g is equal to 5.35 seconds. Okay, 5.35. So now if I have to solve this, let me solve this. So the s is given 122.5, so 2s will be 245. 245 by 10. 245 by 10 will give me 24.5, which I'll assume to be 5. So 122.5 by V is equal to 5. This will become 5 approximately. I'll take it to the other side. 0.35, or V is equal to 122.5 divided by 0.35. So that will become close to 3 times. So 3 times means 366. See, 367. So 367. So this is definitely wrong. This is definitely wrong. This is definitely wrong. So we'll just go for this. The units itself, only this one matches. So we could have just gone for that. A ball is thrown vertically upwards. This is one more thing that I have seen. There are many questions which come, especially in the NEET exam, where the question may appear to be very difficult, but if you look at the options, it will be very easy. So as a matter of practice, whenever you are seeing the questions, please look at the options also. The question may appear to be very difficult, but the options will make it very easy. A ball is thrown vertically upwards. Which of the following plots represents the distance time graph? A ball is thrown vertically upwards. So as you throw it vertically upwards, the speed will keep on reducing. Then again it keeps on increasing. So we will go to option C. A body is thrown vertically upwards with a velocity u, reaches a maximum height h after t seconds. So u is equal to 10 times t. At h by 2 from the ground, its velocity is u by 2. This is definitely wrong. At time t, its velocity is u. This is also definitely wrong. At time 2t, its velocity is minus u. Yes, body time taken to go up is equal to time taken to come down. So this is u, so this is u at 2t, absolutely correct. A ball is projected vertically upwards with a velocity of 25 meters per second from the bottom of a tower. A boy who is standing at the top of the tower is unable to catch when it passes him in the upward, but the ball again reaches him after 3 seconds. So there is a tower, a ball was thrown, he couldn't catch it, but after 3 seconds he was able to catch it. So after 3 seconds means it is 1.5 to go up, 1.5 to come down. So this was 25, this was 25 meters per second. So 1.5 means what? This must be 15. Only then it will go, because deceleration is 10. So per second it will reduce by 10. So this must be 15 here. So from here to here, question is the height of the tower. Very simple. So now what can we do? We can say that from 25 to 15, it will go in 1 second. Then the average velocity is 25 plus 15 is 40 by 2 20. So 20 into 1 is 20 meters. So that is the answer. First picturize the question. This is the tower. From the ground a ball was thrown. He was not able to catch it here, but he was able to catch it on the return. And this time was given to you as 3 seconds. After 3 seconds, that means 1.5 to go up, 1.5 to come down. That means here the velocity is 0. So this should be 15 and this is given 25. So 25, this average velocity is 20. 20 into 1 will give you 20 meters. Look at the 33rd question. A person sitting on the top of a tall building is dropping balls at regular intervals of 1 second. When the 6th ball is being dropped, the positions of the 3rd, 4th and 5th balls from the top of the building are respectively how much? So obviously 5th distance will be maximum, followed by 4th, followed by 3rd. So let's see what's happening. So this is a tall building. So from here they are dropping balls. So when the 6th one is dropped, So when the second one is dropped, the first one has travelled for one time interval, whatever it is. When the third one is dropped, this has worked for two time intervals, this has worked for one time interval. So when the sixth one is dropped, the fifth one has travelled for one time interval, 1t I'll put, the fourth one has travelled for two time intervals, the third one has travelled for three time intervals. Okay. So this total distance from here to here is half into g into 9 squared. For this it is half into g into 4 squared. For this it is half g t squared, whatever it is, t squared will be there common to all. Now the question is that the positions of the third, fourth and from the top of the building. So it is just a simple ratio. So the number should look like for the fifth one it will be t squared, for this one it will be 2t squared, for this one it will be 3t squared. So the time interval will be looking like how much? It will be looking like, or the distance interval will be 1:4:9. Yeah, so it is 1:4:9. Now whether it is 4.9 this or this is also in that same ratio 1:4:9. This one is not in that ratio, this one is not in that ratio, this one is not in that ratio. They want the positions of the third, fourth and fifth. So the third one should be maximum. So this one will be the right option. Okay. If it is 5, 4 and 3, then this one would have been the answer, otherwise this one would have been the answer. Even by looking at the options, you could say that the third ball should have travelled the maximum distance. If the third ball has travelled the maximum distance, A and B can't be the answer, only C and D can be the answer. From among C and D, I think it should be 1:4:9. So option C will be the right one. A person standing on the edge of a wall throws a stone vertically upwards with an initial velocity of 5 meters per second. The stone goes up, comes down, falls on the well, making a sound. If the person hears the sound 3 seconds after throwing the stone, then the depth of the well is how much? So this is the wall, edge of a well, sorry, and from here he is throwing something and it is going something. So this is 5 meters per second. So it will take 0.5 seconds to go up, 0.5 seconds to come down, right? So to find out the depth, it will be the distance travelled from here in 2 seconds. So I can simply say S is equal to ut, so 5t plus half gt squared. So if I substitute, it will become 10 plus half into 10 into 2 into 2, 2 into 2, 2 cancel, so 20 plus this is, yeah, 20 plus 10, 20 plus 10 will be 30 meters. So the answer is 30 meters. Okay. See, this whole idea that if something is thrown with a velocity of, let's say, u, it will go up for a time u by 10. When it will come down for the same time u by 10. So that is the concept that I am using. Also, velocity here is equal to velocity here. So instead of taking the velocity up, I have assumed the velocity to be down, and then I found out S. A ball is thrown vertically upwards with some speed from the top of a tower 200 meters. Another is thrown vertically downwards with the same speed. It is based on the same concept. The difference between their times, between them reaching the ground is how much? So it should be equal to, the first one is going to go up and then come down. So 1 second to go up, 1 second to come down. After that it is same as throwing down at 10 meters per second. So answer should be 2 seconds. A body is projected vertically upwards with a velocity u. It crosses a point on its journey at a height h twice, just after 1 and the 7 seconds. So body is projected vertically upwards and then it is going to come down. Then a particular height h, at a particular height h, this is 1 second and it goes up and comes down after 7 seconds. That means this distance is 6. That means this is 3, this is 3. That means here the velocity is 30, here the velocity is 0. That means here the velocity would have been 40 and 40. So the question is, the value of u is how much? So it is 40. You see, these are quite difficult questions, but if you understand the concept correct, it takes as much time to read the question for you to do it. You can do these questions very fast and you don't need great formulas. You just need to understand, if something is being thrown up because of gravity, the velocity reduces by 10 every second. Time taken to go up is equal to time taken to come down. At a given height, velocities will be the same. While going up, it will be in the upward direction, while coming down, it will be in the downward direction. So those are the concepts that we are using. A stone thrown vertically up from the ground reaches a maximum height of 50 meters in 10 seconds. Okay, time taken by the stone to reach the ground from maximum height is how much? A stone thrown vertically up from the ground reaches a maximum height of 50 meters in 10 seconds. So I have some issue there. So if it is reaching a maximum height of 50 meters, then I can say that S is equal to half into G into T squared. So 2S by G square root is equal to T, and that means it is equal to 250 100 by 10, so that is square root of 10. So I have some doubts how it can happen in 10 seconds. Then time taken by the stone to reach the ground from maximum height is how much? Okay, maybe they are talking of a situation where gravity is not G but something else, and it is taking 10 seconds to go up, and if it has taken 10 seconds to go up, it will take the same 10 seconds to come down because gravity is going to be the same. So I would say it is 10 seconds. A freely falling body travels dash of the total distance in the 5th second. So freely falling body, so if it's a freely falling body, in 5 seconds it would have travelled a distance of half into 10 into 25. In the fourth, by the end of the 4th second, it would have travelled half into 10 into 16. 25 minus 16 is 9. So the answer has to be, so they are asking me, a freely falling body travels dash percentage of the total distance in the 5th second. So this is what it is. Answer has to be a multiple of 9. I see only this number is a multiple of 9, so I'll just stick that. So this should be half into that much, but let me see how I get it. This is again 5, this is 125, this is 80. So 125 minus 80 is 45. So 45 by 125 into 100. So 15 will go 3 times, 15 will go 125, 15 doesn't go. So 5 will go 9 times, 5 will go 25 times, 25 will go 4 times, 9 into 4 is 36. So that's the answer. Two cars traveling in the same direction with a velocity of 60 kilometers per hour. They are separated by a distance of 5 kilometers. A truck moving in opposite direction meets the two cars in time intervals of 3 minutes. Okay. So there are two cars. They are separated by 5 kilometers. Both are traveling at 60 kilometers per hour, 60 kilometers per hour. Okay, now there is a truck traveling in the opposite direction which is crossing them in intervals of 3 minutes. The velocity of the truck is how much? So no problem. So this so the distance between them will remain the same. So the truck is traveling this distance of 5 kilometers in 3 minutes. So in 1 hour it will travel 5 into 20. So 5 into 20 is 60. So the answer has to be 60 kilometers per hour. Okay, let me just think. Yeah, so the truck should be doing same 60 kilometers per hour. So the answer will be 60. Policeman moving on a highway with a speed of 30 fires a bullet at a thief's car speeding away in the same direction with a speed of 192 kmph. If the muzzle speed of the bullet is this, with what speed does the bullet hit the thief's car? Note, obtain that speed which is relevant for damaging the thief's car. Okay, no problem. So 192 kilometers means into 5 by 18. So 18 will go, 18 tenths is 180. 180 it is 12. So assume it is little more than 10. So it is 50 meters per second. So the car is going at 50 meters per second. The muzzle speed of the bullet is 150 meters per second. 150 meters per second. With what speed does the bullet hit the thief's car? So we can talk only about the relative velocity. The relative velocity will be close to 100 meters per second. So we will say it is 105 meters per second. A motorist drives north for 35 minutes. So he drives north for 35 minutes at 85 kmph, then stops for 15 minutes. That means in 50 minutes he has done whatever distance, and continues north traveling 130 kilometers in 2 hours. So he travels 130 kilometers in 2 hours. What is the total displacement? So total displacement will be little more than 130, and since he has already traveled for 35 minutes, only this one will be the answer, nothing else will be the answer. The coordinates of a moving particle at any time t are given by this and this. The speed of the particle at time t is given by. So understand that dx by dt will give you 3 times alpha t squared, and dy by dt will give you 3 times beta t squared. So I can say the velocity is 3 alpha t squared I cap plus 3 beta t squared j cap. Now they are asking me the speed of a particle at any time t. So if I can take 3 and t squared common, so it will be 3t squared square root of alpha squared plus beta squared. So speed is a scalar quantity. Time t and distance x is 2t is ax square bx, where a and b are constants. Okay, the acceleration is how much? So there is a little issue here. So they should have written it as 2t is equal to ax square plus bx. Okay, so the acceleration I'll differentiate it with respect to time. So I'll get 2 is equal to 2ax dx by dt plus b times dx by dt, which means that 2 times ax plus b into v is equal to 2, which means that v is equal to 2 by 2 times ax plus b. Now the acceleration is equal to dv by dt, so it will become 2 into 2ax plus b power minus 1, so that will become minus 1 into 2 into 2ax plus b power minus 2 into 2a dx by dt. This is the acceleration. So let me see how. So it's going to be tough. So there's something wrong here. We will have to understand what is it. It doesn't seem to be just this much. So we will understand what it is. Two cars start in a race with velocities u1 and u2 and travel in a straight line with accelerations alpha and beta. If both reach the finish line at the same time, the range of the race is how much? Okay, so two cars start a velocity u1 and u2, and both, one is moving with the acceleration alpha, one is moving with an acceleration beta. So s is equal to u1t plus half into alpha t1 squared. S is also equal to u2t plus half into beta into t2 squared. Now these two are equal, so from there I can say that u1 t1 plus half into alpha into t1 squared is equal to u2 t1 plus half into beta into t2 squared. So from there I can say u1 minus u2 t1 is equal to half into negative alpha minus beta t squared. So 1t will get cancelled. So 2 times u1 minus u2 by alpha minus beta, or rather beta minus alpha, is equal to t. So once I know t, then I can find out the range. So the range s is equal to u1 into u1 minus u2 by This is 2 times alpha minus beta plus half a t squared. So if I substitute, I will get it, but I want to see alpha is the acceleration. So let me just see, because all the formulas are looking a little different, let me see if dimensions will help me do it. Okay. So alpha is the acceleration, so this is, they are asking you for the range. So this has the dimensions of L t power minus 1. This has the dimensions of L squared t power minus 4. This has the dimensions of L t power minus 1 into L t power minus 2. So let us see what is there. L squared will get cancelled, then t power minus 4 will also get cancelled. So this has the dimensions of length. Now the other ones, will they have the same dimensions? If this has the dimension of length, this will also have the dimension of length. This one will not have the dimensions of length. Okay. Similarly, this one also will not have the dimensions of length. So answer has to be either A or B. So let's see. Okay, so I just have to substitute this. I already found out the value for t. Once you get the value for t, then if you substitute here, you will get it. So let me just erase everything and then I will get it again. Yeah, so this is taking us a little time. Yeah, there is a, so u1 t1 plus half into alpha t1 squared is equal to u2 t1 plus half into beta t1 squared. 1 t1, 1 t1, t1, t1 gets cancelled. So on rearranging them, I will get u1 minus u2 2 times divided by beta minus alpha is equal to t1. Now to calculate the range, S is equal to u1 2 times u1 minus u2 divided by beta minus alpha plus half into alpha into t squared. T squared will become 4 into u1 minus u2 the whole square divided by beta minus alpha the whole square. Okay. So now if I have to work on this, there is a u1 minus u2. So u1 minus u2 will remain. Okay, so here also there is u1 minus u2, there also there is u1 minus u2. Okay, in the denominator I have beta minus alpha, so beta minus alpha. So this is going to be the answer, this one will not be the answer. 3 points, move with uniform accelerations. v1, v2, v3 denote the average velocities in 3 successive intervals of time. So this is t1, this is t2 and this is t3, and here the velocities are v1, v2, v3, that is average velocities are v1, v2, v3. Then the correct relationship among them is what? Okay, so suppose here the velocity is u1, here it is u2, here it is u3 and here it is u4, then average velocity is total velocity, because they are moving with uniform acceleration. Average velocity is u1 plus u2, so u1 plus u2 by 2 is equal to v1 plus u2 by 2 is equal to v2. Okay, then they are having some v1 minus v2, so v1 minus v2. So look, here the average velocity is v1, here the average velocity is v2. Simply speaking, the acceleration will come from that average velocity. Okay, so I can get the average velocity and I can say that v1 minus v2 divided by t1 plus t2 is equal to the acceleration. This is also equal to v2 minus v3 divided by t2 plus t3. So if I go by this concept, v1 by v2 divided by v2 minus v3 will be t1 plus t2. Option B seems to be the right one. But yeah, option B is the right one. So all that I am trying to say is the difference in this velocities in this time interval, so t1 plus t2 is equal to the acceleration. A freely falling body takes t seconds to travel the first 1/8 of the distance. Then the time of descent is how much? So a freely falling body, so half into g into t squared. is equal to 1x of the total distance is equal to half into g into time of descent squared this is equal to x, this is equal to, okay, so half g t squared divided by half g total time of descent squared is equal to 1 by x. So these two will get cancelled, take square roots. So time of descent is equal to t times root over of x. Okay. If a car covers 2/5 of the total distance with 1 speed and 3/5 of the distance with 2v speed, then the average speed is total distance by total time. So suppose this distance corresponds to 2x, this distance will correspond to 3x. So the total distance is 5x. The time taken is 2x by v1 plus 3x by v2. So now if I just do some rearrangement, I will get v1 v2 in the numerator. So I'll get 5 times v1 v2 in the numerator. In the denominator I'll get 2v2 plus 3v1. So this is going to be the answer. A ball is dropped from the 9th stair of a multi-storied building, reaches the ground in 3 seconds. In the first second of its free fall, it passes through n steps or n stairs. Let's say steps. Then n is equal to how much? So basically there are 9 steps, 1, 2, 3, like this there are 9 steps. Okay, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So it goes from 1, reaches from the 9th step of a multi-storied building, reaches the ground in 3 seconds. So it reaches the ground in 3 seconds. So basically I can say the height is equal to half into 10 into 3 into 3. So that is 45 meters is the height. So these are not steps, I think these should be floors. Leave it, 45 meters. Then in the first second of its journey, it falls through 5 meters. So 5 meters means 5 meters is 1 by 9th of it. So totally 45 meters is for 9 floors. So each floor will be 5 meters. So it flows to 1. Two trains A and B 160 are moving in opposite directions on parallel tracks. Velocity of the shorter train is 3 times. This is the shorter train is 3 times. So this is 3v, this is v. If the trains take 4 seconds to cross, 4 seconds to cross means totally 160 divided by 4v is equal to 4 seconds. So from there I can say v is equal to 160 by 16, that is 10. So v is equal to 10. So one is moving with 10, the other one is 3 times faster, so it is moving with negative 30. A stone projected vertically. So here the concept that I used is the total distance is the length of the two trains. Okay, and because they are moving in opposite directions, together in 1 second they will travel v and 3v. So I divided it by 4v. A stone projected upwards with a velocity u reaches 2 points P and Q separated by distance h with some velocities. A stone is projected vertically upwards with some velocity u. 2 points P and Q. So P and Q separated by a distance h with velocities u by 2 and u by 3. The maximum height reached by it is how much? So from here to here it will go u squared by 4 minus u squared by 9 is equal to 2 into g into h. So here if I look at the LCM, it will be 36 and it will be 5. So 36 means 72 GH by 5 is equal to u square. Okay, u square, and I know that h is equal to u squared by 2g. So into 2g will give me the height. So g gets cancelled, 2 will go 32. So the answer is 32h by 5. 36h by 5. So it should be C. See, any question, if you make a plan and then if you understand it, it becomes easy. Okay, so always try to draw some diagrams and then see how you can understand the meaning of the question on the diagram. Once you understand that, you won't be thinking which formula should I apply. Otherwise, as soon as you read the question, the only thing in your mind will be which formula to apply and you will get lost. Okay, so one thing that I'll tell you students is, now you see I am doing physics questions for the past almost 15 years, and every year I work with good number of children and I have to do quite a bit of it. But still the easiest way for me to do a question is to draw a small diagram, quickly understand it and then work. So this way I think you will be faster. Practice, if you practice you will win. Don't think of memorizing, think how you will use the basic concepts that you have learnt and then try to do questions. Okay. So thank you, all the best, keep working out these questions. There is one more set coming in. The next set we will try to discuss the answers in a different way. I will have another teacher discuss the answers so that you will get another way of doing the same things. But my basic principle is, if you begin to think, if you draw diagrams and if you work with fundamental concepts, it will be possible for you to do things very fast. Okay. Thank you and best wishes.